Okay, I think we're live. Let's do some single variable calculus problems. So let's do a reading on graphs, and then I want to solve this problem set. So I want to do, I don't know how much I'm gonna do. I have a class at like 11, so I'm gonna leave around like 10:45, which is like 25 minutes from now. But yeah, I wanna solve as many problems as possible. So I watched lecture one, and then so this should mean that I should be able to solve recitation 0, even though I didn't attend recitation 0 in particular, but recitation 0, and then lecture 1 problems, and then I think this one, this one, this one, this one, and then yeah, this one as well. I do know that these problems are pretty difficult, like they ask you to think a lot, but yeah, it says read notes G, so which is about graphing, so I might as well just read that. I'm gonna full screen this. Yep. Okay. To get a quick insight of how the graph of a function looks, it is very helpful to know how certain simple operations on the graph are related to the way of the function expression looks. We considered these here. Okay. Right to left translation. So let's see greater than 0. Okay. Start with the graph of some function f of x. Keep the x-axis and y-axis fixed. So x is fixed, y is fixed. Remove the graph c units to the right or c units to the left. Okay, so if it's plus c, you just move c units to the right. Minus c, move c units to the left. You get the graph of two new functions. Moving the f of x graph c units to the right, left gives the graph f of x minus c. Yeah. Yeah, so interesting. So you move it to the right if it's x minus c, in the case where c is greater than 0. You move it to the left in the case on x plus c, if c is greater than 0. That necessarily doesn't make sense to me, but let's keep reading. If f(x) is given by formula in x, and f(x minus c) is the function obtained replacing x by x minus c. Yep. Wherever it occurs in the formula. For instance, x squared plus x. So c here is 1. Is x squared minus x. Okay, so sketch the graph of f of x, x squared minus 2x plus 1. By algebra, that is x minus 1 whole square, therefore by 1. Its graph is the one obtained by moving the graph of x square 1 unit to the right. Yeah, x squared, the graph of x squared 1 unit to the right, because it's negative, and apparently you move it to the right when it's negative. Okay, I guess that makes sense right now, because at 1 it's gonna be 0, so when you're moving to the right you're actually decreasing the value, right? Okay. Well, there's a parabola touching the x-axis at 1. So the original one was this, the dotted lines, and then yeah, I'm getting the solid line as x minus 1 whole square. To see the reason for the rule 1, suppose the graph, okay, now they're actually explaining it. Suppose the graph of f of x is moved c units to the right. It then becomes the graph of a new function g of x, whose relation to f of x is described by the following. Value of g of x equals to value of f of x at x0 minus c, true, equals to f of x 0 minus c. So this shows that, yeah, so this shows that g of x equals to f of x minus c. The reasoning is similar if the graph is translated C units to the left. Try giving the argument yourself while inferring to the picture. So every time we're decreasing by C, it's shifting to the right. Okay. The effect of up-down translation of the graph is much simpler to see if C greater than 0. Moving f of x graph up, okay, it's x plus C, down, it's negative. Okay. Since, for example, moving the graph by C units has the effect of adding C units to each function value. Therefore gives us the graph. Okay, so I was thinking of this when this was explained, but this is C is being x minus C is being replaced by every x. So here's the graph of 1 plus root x minus 1. Okay, this is combining the rules of 1 into first sketch root x, right? And then since it's negative 1, we move it 1 unit to the left. Nice. And then since it's plus 1, we move it up. Okay. So this is what we get. And there is no 0 here because this is going to be a root of negative 1, and that doesn't compute anything, or that's imaginary. Sketch the curve of y equals x squared plus 4x plus 1. We complete the square. Okay, so we do x squared plus 4x plus 1. That can be written as x squared plus 4x plus 4 minus 3. Yep, same thing. And then this is x plus 2 whole square, negative 3. So we do x plus 2, we move it 2 units to the left, and then we move it 2 units down. Okay. Changing scales, stretching and shrinking. Okay. C greater than 1. To stretch the x-axis by the factor C means to move the point 1 to the position formerly occupied by C. And in general, the point x0 to the position formerly occupied by Cx0. Similarly, to shrink the x-axis by factor C means to move x0 to the position previously taken by x0 minus by C. Okay, so stretching slash shrinking. The x-axis by C changes the graph of f of x into that of so the switching by a factor of C greater than 1, the function is the same value at x0 that fx has at x0 minus C. Okay, so I'm just gonna do this stretching and what's the other thing called shrinking graph. Okay, this should be better understood, I suppose, through x-axis. Right, so x squared is if we consider that as the baseline, right? When we do 0.5, we're doing a stretch. So what is that doing? So now if we combine the reading with the diagram, right, by factor of C, so this is stretching. So well, it's not, C is not greater than 1 technically here, so I don't know if C can be greater than 1. to move the point 1 to the position formerly occupied by C. The fact this is being stretched. Okay. Oh, I see. C in this case is 2 because it's 1 by 2, right? So let's say 1, right? Let me try to compute this. So whatever the yeah, it means to move the point 1 to the position formerly occupied by C. Well, the point x0 to the position formerly occupied by Cx0. So this value 1, right? So if we consider our x0 to be 1 and our stretch factor is 2, right? Because it's half. So 1 is going to be occupied by 2 times 1. So at the x-axis 2 basically. And if it was 1 over 3, then it would have been this. If it was 1 over 4, would have been here. And then for the this is stretching, and then for what is the other, for shrinking, right? For shrinking it's gonna be since it's half, right? So whatever this value was, you divide that. So if it was 3, then it would have been 1/3, so somewhere around here. Would never go to 0 though. It's gonna like keep steeping up. I think I understand it. Okay, now for the y-axis, right? Let's look at that. Okay, so if the y-axis is stretched by a factor of c greater than 1, each y value is multiplied by c, so the new graph is that of the function c(f(x). Oh, this is probably easier. Sketch the graph of 1 by 2x minus 1. Start with the graph of 1 over x. Move it 1 unit to the right to get the graph of 1 over x minus 1. And shrink the x-axis by the factor of 2. Yeah. So since we're multiplying, so whatever value was at like 1, it's gonna hold that same value at half. So let me just look at this graph. So okay, that's the graph of 1 over x, correct? We move that 1 unit to the right. So this is gonna move 1 unit to the right. This is also gonna move 1 unit to the right, and then we are gonna shrink it because it's 2. So so this is gonna be 2. Let me look at. So this is gonna be 2 1 technically. Reflecting in the x and y axis, even and odd functions. Damn, this one's big. And trigonometric functions. I mean, that's all we're reading though, till trigonometric functions. But yeah. Okay. To reflect the graph of f of x in the y-axis, just flip the plane over around the y-axis. This carries the point xy in the point negative x comma y, and the graph of fx into the graph of f of negative x. The new function is the same y value as x equals 0 as fx. Okay, so it is given by the rule function f of minus x. So same y value for the negative of that x. Similarly, reflecting the xy plane, the x-axis carry the point x comma y, and the graphs get carried to a negative fx. Okay, finally reflecting first in the y-axis and then in the x-axis. So this is called reflection through the origin. The graph gets carried into the graph of minus f. Okay, this is pretty self-explanatory, I think. Okay, so y is x-axis and then origin. Okay, same thing. Okay. Of importance are those functions fx whose graphs are symmetric with respect to the y-axis. That is, reflection in the y-axis does not change the graph. So if we do this, f of minus x, the graph is still the same. Such functions are called even. Functions whose graph are symmetric with respect to the origin are called odd. Okay, in terms of their expression in x. Okay. So show that a polynomial with only even powers like x to the power 4 minus 2x squared plus 7 is an even function. A polynomial with only odd power is an odd function. By the way, explain the terminology even and odd. Okay. 7 for polynomial with respective only even or odd powers. But this follows immediately from the fact that for any non-negative integer n we have interesting. Is an even function. We have so negative x to the power n is basically negative 1 to the power n x to the power n. So it is gonna be x to the power n if n is even. That is true. And negative x to the power n if n is odd. Yep, because whole square, you're gonna cancel out the negative. Yeah, so odd times odd is gonna give us an even. Well, wait 1 second. The following easily rules predict the odd or evenness of the product or quotient of two odd or even functions. So an even function times an even function will give us an even function. An odd function times an odd function will give us an even function. An odd and even function will give us an odd function. And even by even will give us an even function. Odd by odd will give us an even function. Odd by even will give us an odd function. So it is odd. Okay, I get that. So if we consider this is no matter what value you put, even function, even function, odd function, odd function, odd function. This is to the power 0, but if we add 7, is that an even function? It's not gonna give us an even number all the time, right? But we don't need to do that, because yeah, because if we have yeah, I get that. So if we have negative x and the x, no matter what value we put in, it's gonna be the same thing, right? So yeah, and then for this, if we put the negative, we're gonna basically gonna get the negative of, yeah, dy. Fair enough. Okay, the trigonometric functions. The trigonometric functions often for the illustrations of the ideas about translation, changes of scale, and symmetry that we've been discussing. Your book reviews the standard facts about them in section 9.1, which you should refer to as needed. Okay, the graphs of sine x and cos x are sketched below. In calculus, the variable x is always to be in radians. Briefly, there are 2 pi radians and a 360-degree angles. Yep. So that right angle is pi by 2. So fair enough. As the graph suggests, in the unit circle in the picture shows, okay, so cos negative x equals to cos x for even, and sine negative x equals to, so cos x is an even function, and sine negative x is negative sine x, which follows this rule, so it's an odd function. And the standard one sees that 90, so pi by 2 minus x equals to sine x, and since cos x is an even function, so if we reversed it, it also is a sine x, because reversing of this results the same. Okay, that's some interesting inference there. From 11, we see that moving the graph of cos x to the right by pi by 2, so if we move, let me do this, graph of cos x, yeah, because if we move this to the right by pi by 2, circular graph actually, yeah, turns it into the graph of sine x. See picture. Okay, oh, I see. So this is cos x. If we move it by pi by 2 to the right, so this will be here. Actually no, this will be here. This is this, I guess. No, this is this. Since we're moving it to the right, yeah. Which also makes sense because we're doing a negative here, so we're translating to the right. That is sine x. Okay. The trigonometric functions tan x equals to sine x by cos x is also important. Its graph is stretched to the right. It is an odd function by 9 and 10, since it has the form odd by even. Okay. This is big. Okay. Periodicity. An important property of the trigonometric function is that they repeat their values. Okay. So this is so because x plus 2 pi and x represents the radians in the same angle. move the graph of sin x and cos x to the left, but it will coincide with itself. Okay. Questions 13 say that sin x and cos x are periodic function with period of 2 pi. In general, let c greater than 0. We say that fx is period with period c if for all x and c is the smallest positive number for which 14 is true. Okay. Low-key, I need to head to class, but I'll come back after class and finish reading this and then start doing some of the problem. This is very fun and interesting. It's a change of pace from coding, I suppose. Okay, so I'm done with my class. My next class is at 2:30, so it's 2 hour and 30 minutes from now. Had a nice lunch. Let's get back to math. Okay, we were yeah. So this is periodic. We did that. Let's let me see if we move the graph of sin x. It'll coincide with itself from the function. Like see, yep. Okay, by rule one, the graph of the periodic function having a period c coincides with itself when it is translated c unit to the left. If we replace x by x minus c, we will see that the in 14, okay, so x minus c plus c, the c gets cancelled out. The graph will coincide with itself if it's moved to the right by c units. But beware, it is if a function is made by combining other periodic functions, you cannot always predict the period. For example, although it is true that tan x plus 2 pi equals tan x and cos square, the period of both tan x and cos square x is actually pi, as the above figure suggests for tan x. For tan x, so yeah, every pi it's repeating, right? Okay. The general sinusoidal wave, the graph of sin x is referred to as a pure wave or a sinusoidal oscillation. We now consider to what extent we can change how it looks by applying the geometric operations of translation and scale change discussed earlier. Start with sin x, which is a period of 2 pi and oscillates between +1 and -1. Stretch the y-axis by a factor of a greater than 0 by 4. This gives a sin x, which is a period of 2 pi. And oscillates between plus and minus a. Yep. Shrink the x-axis by a factor of k. This gives a sine 2 pi 2 pi by k. Interesting. Okay, let's try to think about this more. Yeah, so shrink the x-axis by a factor k. This gives a sine kx. So k in this case is, since we're shrinking, so it can be 2, 3, 4, whatnot. Okay, which has period of 2 pi over k. So this was 2 pi at first. So x plus 2 pi over k is the same as kx plus 2 pi So if we take the common denominator, that's going to be kx plus 2 pi divided by k. Kx plus 2 pi over k. don't really understand this. How are we simplifying from here to here? Let me ask. Let me see. ChatGPT. Oops. ChatGPT. Close sidebar. Can you explain? Can you explain? Yup. Yeah, because it's the same thing. Mm-hmm. Mm-hmm. Okay. So the period T is such that um, okay. Okay, yeah. So whatever period that is basically, yeah, because this is the same thing. So from here we're doing kt equals 2 pi. Okay, I get that. I think I understand. Also, they're distributing the k. So it's I see. So okay, so move the graph. This is 5, right? 5 units to the right by 1. This gives. So this is gonna be move the graph to the right. Yep. And then this is gonna shrink it. Yep. So which has a period of 2 pi over k. The wave repeats itself. Yep. 2 pi over k times. The angular frequency is k. The k as k complete cycles as x goes from 0 to 2 pi. Okay. The amplitude is between a and minus a, and the midpoint of the wave is at x equals phi. Okay. Depends on three constants. Constants k, a, m. We call such constants parameters. The value determines the shape and position of the weight. Okay. It is possible to write 15 in another form which also has 3 parameters. Okay. A equals I don't understand this. Okay, so A equals A cos k, B equals negative A. So these are same, right? Well, not really. If we do negative of cos, we get no. If we shift cosine, we get that, right? So yeah, if we shift it by pi by 2, we get sine x. There we go. So okay, think they're proving it. Proof of the equivalence of 15 and 16. Identity sine a plus beta equals sine alpha cos beta plus cos alpha sine beta. We get a sine, distributing it, and then we're applying this formula right here. This is the form of 16 with the values for a and b given in so this is just defining a and b. Okay, 17 with the 15 squared the two equations on the left of 17, add them. This gives we get, okay, this is a very mumbo jumbo proof, but Jesus, it's big. What? Oh, okay, so this ends right here. Okay, let's see. So okay, so we have a sine kx plus b sine kx, right? And then we know a equals a cos, if we consider this, b equals negative of this, a equals a square plus b square. Okay, from the identity, okay, so we're gonna basically prove these, right? So we know this is true. Sine alpha plus beta equals to sine alpha cos beta plus cos alpha sine beta. So from that we get if we do a sine kx minus the phase angle, right? And that is equal to this formula, which has the form of 16 given in 17. Okay, 15 squared the two equations on the left of 17. Okay, a square plus b square equals to a square equals to a square. This adds up to 1, showing that a equals to a square plus b square. If with the ratio of the two equations, we get minus b by alpha equals to tan k. I'm gonna ask, this is, I sort of understand it, but not exactly fully. Okay, so from 16 we have this a sine kx plus, which is the same as, these are equivalent, just written differently. Okay, this is the claim, and we're gonna have to prove that claim. Okay, I believe that this identity exists. I know. Okay, sine alpha cos beta minus cos alpha sine beta. So alpha is equal to kx and beta equals to Okay, this is an interesting proof. So what are we doing here? We are considering A as or alpha, right, from the identity, as kx, right, and beta as k theta, right? So, or that's not theta, I don't know what this sign is called. Epsilon, not epsilon, phi maybe. Okay, so we are considering that. So if we consider this as alpha, this as beta, right, we can expand this to get this. Okay, and then what's up? So yeah, the identity is my A is okay, so A is this part, right, and my B is this part, right? A is, yep, and B is negative, yep. Okay, so we get that identity, and then we're doing a square plus b square. So we know this is 1. So negative b man, so on the left of 17. So if we take this, okay, is equal to negative, yep. So this is negative b by this time as a horizontal shift. Okay, so this is the horizontal shift, this is the amplitude basically, right? Okay, find the period. Okay, frequency, amplitude, and phase angle of the wave represented. Okay, this should make it way clearer. An example. So 2 sine 3x minus pi by 6. Writing the equation in the form 15, we get 2 sine 3x minus pi by 18. So in the form of at 15, so this way, right? Okay, which shows that it has a period of 2 pi over 3. So 2 pi over 3, frequency of 2, frequency of 3, sorry, this is the frequency, amplitude of 2, and phase angle is this one. I see. This is the frequency. Okay, we get rid of the sign by using minus cos x equals to cos x minus pi, translating the cosine to curve pi units to the right, the same as reflecting it in the x-axis is the best way to remember such relations. So that is equal to 2x minus pi, divide that by 2x minus pi minus pi by 2. I think this is just a simplified version of that. Yeah, and then since we're subtracting by pi by 2, we can basically write it as sine, but just get rid of the pi by 2, right? So that's what they're doing. And then this is the old form, which means we have our amplitude, our period, our angle, right? So there's that. Okay, that is this is a very interesting. This is the hard part here, getting rid of the sine. So translating the cosine curve pi units to the right is the same as reflecting it in the x-axis. That is a loaded sentence. Okay, let's see. So cosine is pi antiperiodic. So x plus pi, so cos x plus pi. Oh, cos x is the x coordinate. Adding pi moves you to the, so it's opposite point of the circle. So it's pi is we go this way, right? So pi by 2 pi, so it's gonna go from the x coordinate to the negative x coordinate, and that's where sine is positive. So coordinate changes the sign. Okay, cosine is even and periodic. Oh, we're doing negative because we want the negative thing in the end, right? We can also do positive. For sine, however, we can only do the negative, right? Or the positive, actually, if only the positive. Its cosine is even and periodic. I'm gonna ask it to explain it again. Explain this again. I still don't get it. Okay. If you do pure algebra and then graph, okay, let's try to do the unit circle first unit circle. Let's do the identity cos A plus B equals to cos A cos B minus sin A sin B. Okay, I get that. Let B equals to pi. Okay, so cos x plus pi equals to cos x cos pi minus sin x sin pi. Okay, so cos pi is -1, sin pi is 0. So yeah, I mean I get that, but then why is x minus pi? So okay, so this is at x equals to, so we shifted pi units to the right, and then this evaluate x equals 0, so that is -1, which is exactly minus cos 0. That's cos x equals 0 is cos minus pi, which is -1, which is exactly so cos 0 would be like this. So I see. Yeah, so it's even, it's an even function, so f of minus x equals to f of x basically. To sketch the curve sine 2x plus cos 2x, transforming it into the form 15, we can get a and phi using 19. Okay, so it's we're transforming it to the form, so transforming it into this form basically, and then we're getting it through what? So it's using 19. But yeah, basically we're doing this, right? So A is so that is the so amplitude is √2, period is pi, what? Frequency is 2 and phase angle is 3 pi over 8. Period is pi. That is interesting. Period is pi. How is that happening, I wonder? Oh, my bad. It should be 2 pi over. Oh my god, it's 2 pi over 2. That's pi. Yeah. This is fun. I'm gonna start doing the actual work, but before that, I'm gonna search for any videos that I can find on the internet and then watch something on this, because I feel like that's gonna make it clearer before I actually start the problem sets themselves, which So it says 1. Okay, so I'm supposed to do 1a, which is by using completing the square. Okay, so that's not too bad. 2a, which is, that's not also too bad, although it's not gonna be 3abe. Identify each of the following as odd, even, or neither. I mean, that's not too bad as well. Suppose 6a, this is gonna be good practice. And then 7a, that's also gonna be pretty good practice. Okay, so I don't know if I should watch a video at first and then solve this, or start solving this, and if I get stuck I'll watch a video, because I don't want to use AI to help me solve the problems. That's like that beats the purpose. I mean, I can use it to check, but no point in help making me solve it. Okay, got some water. Okay. Now, I think I'm gonna just do the problems that started and use AI to help me. And then watch a video if I get really stuck, like for hours on it. Other than that, I don't see a reason. Get my calculator. Okay. So I'm gonna try to solve it on Canva. I'm gonna solve it on paper at first, and then you know, if I feel like I have the right answer, then I'll try to solve it on Canva. Okay. So let me just do it on pen and paper, and then I'm gonna start doing it on Canva. So it says 1A, 1A, right? So I'm just gonna download this. Yeah, so graphing. Okay. y equals x squared minus 2x minus 1. Isn't that x minus 1 whole square? Is it? Let me just check. It's not. That would have been if it's plus 1, so I need to complete the square. So bro, it's been so long since I did this. Completing the square. Yeah, there's a formula. I forgot the formula. I'm so bad at math now. Completing the square. Yep, I'm just gonna. Oh, what do you know? I used to watch
so you're gonna
this
have plus
back
something
in the day.
and plus something. Hi guys, I'm Nancy. And I'm going to show you how to solve by completing the square. What is completing the square? It means getting your equation into a neat, perfect square form like this, where you have x plus or minus a number squared equals another number. Why would you want to solve this way? Good question. It's not the best way, usually. It's usually easier or faster to solve by factoring, if possible, or quadratic formula, which you can always use. But probably you've been told that you have to solve by completing the square, so you need to know how to do it. So I will show you the easiest way.
For easier
X squared
graphs.
is your highest term. Another case is if you have a coefficient greater than 1 in front of your x squared, like 2x squared, 3x squared, etc.
Okay, let me see.
So always just move that constant over the right. So what you get is x squared
So
plus
okay,
6x.
we move the constant away. We divide this
In this
by
case,
2 if I'm not
divided by
wrong.
2. Change the overall value of the equation so that it's squared, which equals 9. So we'll be adding.
Okay, so we're gonna do x squared minus 2x equals 1.
9 to the left side and the right side. So here we fill in plus 9, plus 9.
So we add. Okay, I think I get it. I get the gist. So we do that. We do x squared minus. Okay, so so if we look at the graphing, first it's gonna be my x squared graph, right? And then we're gonna move it 1 unit to the right. So then 2 unit down, right? think I solved it. Let me try to do it on Canva. Okay, so we have y equals x squared minus 2x minus 1. So we do completing the square, right? So the way we do it is we do x squared minus 2x and then we add 1 to both sides. So if we do this equals 0, right? If we add 1 to both sides, we get x squared minus 2x equals 1. And then so we need to do a whole square of this. So we need something like x minus 1 whole squared, right? Well, for us to do that, we divide this by 2, right? And x minus 1 whole squared gives us 1 in the end. So we need to add 1 here and add 1 here. So in the end we get we need to add 1 here. So this is actually x squared minus 2x plus 1 equals 2. So we get x minus 1. This computes x minus 1 whole square. This is 2, right? So now we can just draw the graphs. At first we can draw x squared, which is not exactly accurate. I mean, this is gonna be the main point, right? I forgot what it's called. The minimum point. Then for -1 we shifted 1 unit to the right, so something like this. And then if we subtract 2 from both sides, we get minus 2 equals 0, right? So we basically the graph goes 2 steps down, the entire graph. So it's gonna be something like this, right? Where we can think this is -1, right? Because if we compute this at 0, we get 1 minus 2, which is -1. So the entire step is basically going just 2 steps down. So it was 1 here, and now it's like -1. So from 1 we're going to 0 and then to -1. Okay, so 1a is done. Let me see if I have I do have the solutions. What is it called? Review problems and solutions. Okay, so I have the solution for 1a. Okay, they didn't draw the graph, but yeah, this is basically what I got. Okay, now we do 2a. Okay, 2a is y equals 1 plus x plus 2. So that is simple. So at first we can do just x, mod x basically, or absolute value of x. We shift that 2 units to the left. So it's gonna be something like this, and then we move it up by 1 unit. So 3, something like this. Okay, let's see if my solution is correct at first. What was the thing? It was 2a. So 1a4, 1a5, 1a9. Sure. Where are we going? This is, yeah, all the one has been done or not. Two A. What does it mean by 2A? Yeah, I think what it means is just this, right? So 1A, so it should be two A, yeah. Oh yeah, this is the graph, and then yeah, I got this exactly. So let me just explain somewhat. So what do we have here? So we have okay, so we have y equals 1 plus x plus 2, right? So if we do for modulus of x, we get this because all the negative values they shift up, right? Because it's mod. Okay. Now if we add 2 to this, right, we get 2 units shifted to the right, correct? So we're gonna get something like this. Okay, and now we just shift it up by 1, right? So yep, shift it up by 1, so we get something like this. And then I'm guessing this is 3. So that is the graph. Okay, now we're supposed to do 3ABE. So identify each of the following as even, odd, or neither. So what do we have here? We have, let's zoom in. So we have x cubed plus 3x 1 minus x to the power 4. Isn't this like neither technically, because we have x to the power 4? Yeah, I'm just simplifying this. Let me look at the notes. So odd or even, there was 2. Yep. So if my f of minus x equals f of x, that means it's even. If it's f of minus x equals minus f of x, that means it's odd. Okay, so the best way to prove it is we also have these formula, right? Okay, so my x cubed is an odd function. Like, I know that much. X cubed is an odd function, and so is 3x. That's also an odd function. So now it's so we have an odd plus, so the numerator is odd. Now the denominator, so you have 1 minus x to the power 4. Okay, so that can be written as 1 whole square minus x square whole squared, right? That's it's an even, that can be written as 1 plus x squared 1 minus x squared. So that's an even function. That's an even times even. So we are doing odd by even, which is odd. So the first one should be an odd function. Let me see if I was right. So it's odd, yeah. So I think my proving is very different, but let me try to do it. So it's so we have x cubed plus 3x, right? And then we have 1 minus x to the power 4. So we know that this is odd because this is a power of 1, right? So then this is an odd power, this is an odd power. I mean, we can also prove it, like if we do if we consider x as 2, we're gonna get some value, and if we consider x as negative 2, we're gonna get the negative of that value. Like that's pretty obvious, right? So if this is odd, now we just need to calculate this. Honestly, we probably didn't even so yeah, we just need to calculate this, because if this is odd, then we would have gotten an even function, but this is not odd. So we can write this as 1 minus x squared, right? So 1 whole squared x whole squared, and this can be written as 1 plus x squared 1 minus x squared, and we know these are both even functions. So even times even is even, so odd by even is odd, and this is an odd function. Okay, so 3ab sine squared x. That is interesting. So sine x is an odd function. So doesn't necessarily mean squaring it is odd. Squaring it could be even, because what are we doing when we are squaring something? We're doing odd times odd, right? When we're squaring something, which is an even function, right? Sine squared x should be an even function. Yep. So the way I did it was, we know sine x is so even, right? So we know sine x is an odd function. So we had sine squared x in our question, so that's basically sine x multiplied by sine x, which is odd times odd. That gives us an even function, so this is an even function. Okay, e. So we have j0x squared, where j0x is a function you never heard of. That is very analytical of a question. Well, we don't know, because or do we know? I think we can, yeah, we probably do know. So all the x is gonna turn to x squared, right? So that basically implies it's an even function. Exactly. I think their proving is different. They're doing the whole minus x, but I'm more of like doing this. If it's even, then it's even, right? Okay, so that part is done. Okay, 6a and 7a. So let's do 6a and 7a. Okay. This is where things are probably gonna get hazy for me, but let's see. So we have sine x plus root 3 cos x. So we're gonna have to write that in the form of a sine x plus c, right? X plus c. Okay. Let's look at all the things that we learned. So we can't have any cos or cosine, right? So one thing that comes to my mind is we can write this as sine x plus root 3 cosine pi by 2 minus x, right? Yeah. Or sine interesting. So I clearly I need more understanding for the trigonometric identities because I'm not able to solve this as easily as I thought I would be able to. I know this is pretty easy. But for 6a, right? So we need to get rid of the cosine. What? I'll be back. let's get back into it. I'm not gonna watch any video till I can like figure it out properly, or like I give it like a good shot. Let me make some coffee. I feel like that'll help me for sure. Okay, let's get back into it. Okay, so what was it called? We were doing sin x plus root 3 cos x. Okay, so it's this form, right? So we're practicing that. So we're gonna have to express that in the form of a sin x plus c. Okay, so if a equals to So we have um, hmm. I think I have some idea how to do this. One more till I try. So my a is gonna be a square plus b square. So that's 1 squared plus root 3 whole squared, right? So that is my a is gonna be 1 squared plus root 3 whole squared. That's 2. So my a is basically 2, right? So we have our a. And then we need the phase angle, right? And then all we need is the phase angle, and that's about it, right? This is not gonna be any period here because it's all x, right? K is 1 here, so all we need is the phase angle. So for the phase angle, is gonna be if we do tangent inverse, right? Yeah, so if we do okay, cool, I think I got it. If we do tangent inverse of negative root 3 by 1, we should get the phase angle. It's gonna be in radians, so I think I got it. Radians, so tangent inverse of negative root 3, okay, that's 1 minus 3 pi. So this expressed in this form should be 2 sine x minus 1 by 3 pi. Let's see if I'm correct. I'm not correct. Oh, well, no, I am correct technically. So my A is correct. Should be a plus. So this is correct. So I got negative pi by 3. It's apparently positive pi by 3. Where am I going? What did I do wrong? Here equals to minus okay, so it's b by it's negative only because of this right here, right now, correct? Okay, think I understand it. Let me look at this. Okay, so let me see. So this is how I did this. Okay, so okay, so we have sine x plus root 3 cos x, right? So we have sine x plus root 3 cosine of x. This is exactly in this format, right? So for we need to we're asked to put it in this format. So we need to find the amplitude. The amplitude is just a squared plus b squared, so the coefficient, right? So this is 1 and this is root 3, so that is 1 squared plus root 3 whole squared. So in that case, that's gonna be 2. So we have 2 sine x plus, now we need to calculate the phase angle. The phase angle, this is where I was confused. It says negative b by a, but I feel like the reason why it says negative b by a is because in here it's negative a, right? So when we do the whole simplification, it turns out to be negative b by a, but in the end we can just get the angle by just doing b by a, right? So the phase angle, maybe that's the reason, or maybe that is not the reason. Who knows? But that's what I thought. So what I did was I did tan inverse negative root 3 by 1, which gives us 1 by 3 pi, so we can do pi by 3 here, right? And yeah, that's the answer. um Let me just ask GPT about the whole negative p by 8 part though, because I think I understand it, but my understanding could be wrong, and I'm just reinforcing it, right? So let me see. Chat GPT. Oh, I can't add any more pictures. I. Oh, I can just do this. Root 3. Solve and explain. Okay, so this is doing it more concretely, right? So it's using this formula, so it's working its way back up, which is how I should have done maybe. So it's doing so a sine x plus c, right? So it's doing the identity, right? And then it's comparing the coefficients. So a cos c is 1 and a sine c is root 3. That way we get 4. And then yeah, that's basically what I thought. Okay, so my understanding is correct. This ChatGPT just derived the entire thing from here, which I feel like is a better explanation, and probably a better way to do it. So it started off with the whole a sine a alpha plus beta, right? And then it did a sine alpha cos beta plus a cos alpha sine beta, which is which is this part. And then it compared the coefficients. So a cos c is 1, a sine c, and then it did a whole squared, and then yeah, okay, so that part is done. Now we can do 7a, which is find the period, amplitude, and phase up, and use these three to sketch the function, right? Okay, so the amplitude is 3, right? And then for the other part we need to rewrite this in a better way. So we can write this as 3 sine 2x minus pi by 2, right? So the period is it's a period, right? So the phase angle is pi by 2, right? And then the angular frequency, it complete k complete cycles, that's 2, right? it completes 2 complete cycles from 0 to 2 pi. Okay, so now let's sketch this thing out. So let me just look at the basic sine graph. So this is the basic sine graph, right? So this is gonna be something like this first, and then from the basic one we get an amplitude of 3, so the whole graph moves 3 units up, and then a period of 2, so that means more cycles, and then negative pi by 2, so it's shifted negative pi by 2 to the right, or the midpoint is pi over 2. So okay, I think I got it. Let me just yeah, so let me just try to explain this as best as I can. Okay, so we have 3 sine 2x minus pi. Okay, so we have 3 sine 2x minus pi, right? So we can write this as 3 sine 2x minus pi by 2. It's basically the same thing. So if we do sine x, that is something, no, what am I doing? That is something like this. Yeah, like something like this, with every pi we get like one wave. So I guess this would be one wave, so this would be pi, something like that. Okay, so now we add 3 to it, so it's gonna go up, right? So it's gonna go up, so something like this. Yep, so it goes up. However, we're not so it's still, this is like still every pi, and then once we add 2, there's more frequencies right now. So so you can see that it's happening every pi by 2, and then for the negative pi by 2, I definitely need more work on my trigonometric. Identity, trigonometric drawings. So this is the midpoint, right? Pi pi over 2. The amplitude is 3, so the peak is 3. And then, yeah, and then for the thing about 2 is, it's, so earlier it would have been at 2 pi we would have seen this. So we see a peak up here, right? So pi over 2 pi. So if okay, so by my understanding, right, if this didn't exist, then we would have had the peak right up here, and if this didn't exist, we would have had the peak, or the only peak right up here, and then happen again after 2 pi. But since it's 2, we're having 2 every 2 pi's, right? So, or 1 every pi, and then 3 is pretty easy. So that's what I'm guessing is okay. I mean, I think we did okay. Some of the graphs for the sine thing, at least the last one, could have been clearer, but otherwise we didn't do too bad. I'm not gonna read because I don't have the book, so I'm just gonna do the work, which is 1C3ABE, and then 1B2, 1C, 1A. Okay, so that much we'll do, and then we'll do these as well. Okay. Let's see, 1C3ABE. So 1C 3ABE. Calculate the derivative of each of the functions directly from the definition. Okay, so 3a is 1 over 2x plus 1. So let me see if I have the notes up. Lecture notes, PDF. Yep. And the formula was, this was the formula for derivative, so we can just use that. Okay. So the formula is as the limit is going 0, x plus delta x minus x divided by delta x. Okay, so f of x plus delta x minus the f of x, so change in x by change in y, divide that by delta x, right? So change in y divided by change in x, basically. So in other words, this is gonna be 2x plus delta x plus 1 minus 1 by 2x plus 1 by delta x, 1 by delta x. Two x plus delta x plus 1, 2x plus 1, 2x plus 1 Let's see if my answer is correct. I computed it. It came out to be negative 2 divided by 2x plus 1 whole square. So hopefully it's correct. Oh, where is the answer sheet? Solutions to exercise. Okay. This is 3a. 1c 3a. Yep, there we go. Okay, let me try to explain how I did it. Okay, so what else do we have to do though? We have to do I don't need the graphing functions anymore. We have to do 3abe. Okay, so we need to do b. Should be easier. And then e. Okay. This is directly from the definition. I mean, we have this proven. I'm gonna use that one for the second one, honestly. Okay, so the definition, right? So the definition is we do change in our f, divide that by change in our x. So in this case, our x was 1 by 2x plus 1. So it's 1 by 2x plus 1, right? So we need to do so we'll do f of x plus the delta, right? Delta of x subtracted from f of x, divide that by the change in x, right? So if we plug those values in, we get 1 by, so for in x we'll do x plus delta of x, so 2x plus delta of x, right? And then plus 1, and then we're gonna do a subtraction of 1 minus 2x plus 1, and then this is gonna be divided by delta x. So we can move 1 by delta x outside, and what we get here is if we take the common denominator, right, we get 2 x plus delta x plus 1, right? And then this is multiplied by 2x plus 1, right? And then if we try to compute the numerator, we basically get 2x plus 1 minus 1, and that thing is multiplied by if we simplify the inner term, it gets multiplied by 2x plus 2 delta x, right, plus 1. Okay, now we can do a lot of cancellations actually. So if we multiply the entire thing by -1, we get 2x plus 1 negative 2x, right? -2 delta x -1. So the 1 and 1 cancel each other out, the 2x cancel each other out, right? So in the end we're left with -2 delta x. Divide that by the denominator. I'm just not gonna write that, and then we can cancel these out, so we're left with -2 actually only, right? Divide that by 2x plus delta x, right, plus 1, and then 2x plus 1, right? And since delta x is going to 0, so we can compute this to be 0. So in the end we're left with 2x plus 1, 2x plus 1, and multiplying these two is basically the same as -2 2x plus 1 whole squared. So that's the answer that we get, and they also did it step by step. Okay, now B. For b, I'm just going to use the power rule that we saw. So we have 2x squared plus 5x plus 4. If we do if we calculate the derivative, that's 4x plus 5, right? For b. Oh, they did the whole step, so I'm just gonna do the whole step out of respect, because if they did the whole step, then I think it makes sense for me to do the whole step. So okay, so it's gonna be 2x plus h whole squared plus 5x plus h, and this is as h goes to 0, plus 4. Subtract that from 2x squared plus 5x plus 4, divide that by h, so we get 1 over h 2x squared plus x squared plus 2xh plus h squared plus 5x plus 5h plus 4 minus 2x squared minus 5x minus 4. So 2x squared plus 2x 4xh, right, plus 2h squared plus 5x plus 5h plus 4 plus 2x squared minus 5x minus 4. So we have 1 by h, 2x squared gets cancelled out, 4xh 4xh 2h squared 5x and 5x gets cancelled out. So we have 5h plus 4. This 184 gets cancelled out. Okay. Okay, so now we can do h 4x plus 2h plus 5. Okay, so let me do it properly right now since I solved it. Okay, this one's easier than the previous one actually. So okay, same formula, right? This is the formula. Okay, so we have our equation is, I'm just gonna write the equation here, is 2x squared plus 5x plus 4, right? So let's do x plus delta x, so that's gonna be 2x plus I'm just gonna write it as h, it's easier instead of just like drawing delta every time. So h is some small change in x, right? So we have 2x plus h whole squared plus 5x plus h plus 4, subtract that from f of x, which is 2x squared plus 5x plus 4, and divide that by h. Okay, so we can take 1 over h, and then what we get here is, if we expand this, right, we get 2 x squared, so we get 2x squared plus 4xh plus 2h. So this is expands to x squared plus 2xh plus h squared. Right, and then we multiplied by 2 on the outside as well, right? Okay, this gets evaluated to 5x plus 5h, right? Yeah, so this is x plus h, so this gets evaluated to 5x plus 5h plus a 4, and then this entire thing is basically 2x squared minus 5x minus 4, right? Now we can cancel a lot of terms, so these subtract away from each other, this subtracts away from this, and then this subtracts away from this, correct? This is h, by the way. Okay, what we're left with in the end is 1 over h 4xh, right, plus 2h squared plus 5h. That's all we're left with, right? So if we factor out h, we are left with 4x plus 2h plus 5. We can cancel these h. Now we can finally take h to 0, so then this basically is 2 times 0 is 0, so in the end we're left with 4x plus 5, which is the answer. Yep, there we go. Okay, now part E. For each of these points, find points where the slope is. Okay, so we're going to find the points where the slope is plus 1, minus 1, comma 0. So that's not that hard. So the first one was -2, right? 2x plus 1 whole square. 2x plus 1 whole squared. So when the slope is plus 1, that is going to be 2x plus 1 whole squared. The slope is never plus 1. To the first one. The slope is -1. So we get 2x plus 1 whole squared, so 2x plus 1 equals root 2 plus minus, so 2x equals 2 never 0. Finally it's 4x plus 5 at 1, so 4x equals 6, x equals 6 by 4, 3 by 9. think I solved it. Let me check. Yep. Okay. Pretty simple. Okay, let's try to solve that. Okay, so we have for part A, right? Let me erase everything. Okay, so for part A we had negative 2 2x plus 1 whole squared, and so we're supposed to find when the gradient is 1, -1, or 0. So this is going to equate to 1, and we know that this is never true. We cannot do root of a negative number. Likewise, if we do with 0, this possibly cannot be true, because the numerator is -2, right? So it's impossible for it to be 0, and it's possible for this to be -1. So for that that's basically, we can write this equation as 2x plus 1 whole squared equals 2. So that means 2x plus 1 equals plus or minus root over 2. So 2x equals to plus or minus root over 2 minus 1. So 2x equals to plus or minus root over 2 minus 1 divided by 2. So that's the x. At that x value, at these two x values, the slope is -1, right? And the other one is actually simpler. Second one was 4x plus 5, right? So we can do 4x plus 5 equals 0. So x equals to -5 by 4. That's when the gradient is 0. We can do 4x plus 5 equals 1. So that's equals 1 minus 6, that is -5. So at -5 by 4, the gradient is 1. And then 4x plus 5, you can do that with -1. That is -6. So at -2 by, or 3 by 2, we get a gradient of -1, right? Yep. Okay, now we're supposed to do so I have classes in 15 minutes. Okay, I think that's still enough time. We should be able to do hopefully all the lecture 1 thing. I don't know how big the rest of them are going to be. Okay, 4a. Write an equation for the tangent line to the following functions. Okay, so we already did 1 by 2x plus 1. We know that the derivative function is, the derivative is 2x plus 1 whole squared, right? So we can do y minus so what is the value of y at x equals 1, right? So calc y minus 1 by 3 equals to negative 2 plus 1 whole squared. That's negative 2 over 9 x minus 1. So y equals to 9 plus 2 over 9 plus 1 over 3. So let me see if my answer is correct. 4a is yep, my answer is correct. 2x plus 5. Okay, let's understand how I am able to reach this answer. For a b, so we need to do a and then we need to do b, which is the same as okay. And we can do 5 and 6. Okay. So let's see. So for 4a, right, we have we know the derivative function for this is negative 2x plus 1 whole squared, right? So we want to know the equation of the line at x equals 1. So the formula is y minus y0 equals mx minus x0, right? So our y0 we need to find out. We already know our x0, which is 1, so y0 is just going to be plugging that into the function, which is 2 plus 1. So 2 plus 1, that is going to be 1 over 3. So y minus 1 over 3, and our m is going to be plugging 1 into this one, which gives us negative 2 over 9, right? And then x minus 1. Simplifying this in the end gives us negative 2 over 9x plus 5 over 9, which we can write as negative 2x plus 5. Now let's do for b. So b says at x equals a. Okay, so we'll be working with a lot of alphabets. So at x equals a, my gradient is going to be 4a plus 5. So we're going to do, and then my y is going to be y minus 2a squared plus 5a plus 4. 4a plus 5x minus a. So y minus see if my answer is correct. Yep. Okay, so this is pretty simple, just a lot of alphabet instead of number. So we know our gradient function was 4x plus 5, right? And then our original function was 2x squared plus 5x plus 4. So 2x squared plus 5x plus 4. So we need to do y minus y1, and y1 is going to be just plugging a here. So that's going to be 2a squared plus 5a plus 4. And our m is just going to be plugging a here. So that's going to be 4a plus 5 x minus x1 is a. So simplifying this gives us y equals 4ax minus 2a squared plus 5x plus 4. If we group the x terms together, we get x equals 4a plus 5 minus 2a squared plus 4. That's the equation. Okay, so we did 4ab, now we can do 5. So it says find all tangent lines to the origin to the graph of y equals 1 plus x minus 1 whole square. So what does this mean? All tangent lines to the origin to the graph of. So what is the origin of the graph? So that's when x is 0, right? What is the origin of a graph? What point is origin of a graph? Well, when x is 0, I don't get 0, I get y is 2. So it's 0, 2, and then when y is 0, y is never 0. So we have 0, 2. Let me just draw the graph. Maybe that's gonna make it clearer. So 1 plus x minus 1 whole square, right? Okay. Find all the tangent lines. What is the graph? Y equals to 1 plus x minus 1 whole squared. How do we even do that? Okay, so we just need to draw. There is nothing. What is it saying? Okay, so there is a solution. I didn't understand the solution, so that's good. I'm just gonna try to figure out the solution. Hmm. One plus x minus 1 whole squared. How do we even do that? All tangent lines. Strange. Well, I'm gonna have to head to class. I'm gonna try to solve this after I come from class. Yeah. Okay, so I'm back from class. However, I have something to do for which I'm not. I can't continue streaming. I'll try to solve that problem later off stream, and then tomorrow maybe on stream I'm gonna do some coding right now. Well, I'm gonna learn something, but I'm gonna do that off stream right now.